Lesson 8-2, Substitution. And in this lesson, you learn to solve systems of equations by using the substitution method and to organize data to solve problems. Okay, why is it important? Because you can use systems of equations to solve problems involving geography and accounting. And now let's take a look at an example in geography. New York recently lost its position as the second most populous state when Texas slipped into the number 2 spot. Census Bureau projections show that New York will likely be pushed even farther down the population ladder when Florida catches up early in the 21st century. And that's where we are right now in the 21st century. Okay? So, if New York's population grows at a constant rate of 0.03 million per year, and for Florida's population grows at a constant rate of 0.24 million per year. Okay, when would Florida catch up to New York in population? That would be their what would be their populations then? Okay, so in this case, okay, we let P represent the population in millions and let T represent the amount of time in years. So you now have two variables here. Okay, we want to find out when New York and Florida's population would be equal. Okay, and at the same time, what would their populations be at that particular time when both of their populations are equal. Okay. So two things we need to know. So let P represent the population in millions and let T represent the amount of time in years. The information above can be described by the following system of equations, which is P equals 18.2 plus 0.03T, because this is the annual growth of the population in New York, and 0.24T is the annual growth of the population in Florida. 18.2 is the current population of New York when this census was taken, and Florida is 14.9, which is here. Let me just show you where I found those numbers. I did not invent them, I promise. They're right here. 18.2 and 14.9 for Florida. Okay? So we have a system of equations, and you can try to solve the system of equations by graphing, as shown at the right. Okay, remember that when you talk about graphing, it's not an exact science. Notice that the exact coordinates of the point, where the lines intersect cannot be easily determined from this graph. An estimate is 16 and 19 is probably close. So when you graph these two equations and put them here, right there, that particular point right there is not easily shown. So we can approximate this to be 16 and 19. Okay? Now, if we do this, the exact solution of this system of equations can be found by using other algebraic methods. One such method is called substitution. So when you use the graphing method for solving a system of equations, it is not an exact method to use, because you are looking at the graph and sometimes you cannot decipher the point on that graph. But one way to exactly find the solution for that system would be called the substitution method. So from the first equation, P equals 18.2 plus 0.3T, you know that P is equal to 18.2 plus 0.03T. Since P must have the same value in both equations, you can substitute 18.2 plus 0.3T for P in the second equation. P equals 14.9 plus 0.24T. Too many P's and T's. So what it's basically saying is this. So if P equals 18.2 plus 0.03T, then I can get this entire thing and substitute it to that p. Okay, so if we do that, this is what's going to come out. Okay, so we go back, okay, to our equation. If I can find it somewhere here. It's probably here. Oops. There you go. So P equals 14.9 plus 0.24T. We are going to substitute the value of P, like what we talked about. Okay, and the value of P. Oh, let me get that thing, get that. Oh, let me get all of them out of there. There you go. Let me delete all of them. There you go. So you can see that. So we substitute the value of P to be 18.2 plus 0.03T, which is right here. We talked about that. Okay. And then after we equate that, we simply solve for, okay, the value of T for now. Okay, because you have now an equation with only one variable. Now we have a variable on both sides. This is easy for us to solve. So we simply subtract 18.2T to both sides. Okay, sorry, subtract 18.2, okay, to both sides of our equation. We end up with 0.03T equals negative 3.3 plus 0.24T. And then what we want to do is we need to isolate T to one side of the equation by subtracting 0.24T. Okay, so basically subtracted 0.24T to both sides. Oopsie. 0.24T to both sides. 0.24T to both sides of our equation. We subtracted that also to the other side, and we ended up with negative 0.21T equals negative 3.3. And then we simply solve for T. Okay, and solving for T, again, why is it not showing up? I don't know why it's not showing up. Okay, we'll just write it down then. Okay, so we basically solve for T. Okay, let me see why it's not showing up. Okay, let me just write it. So T, divide both sides by, it's negative 3.3 divided by negative 0.21. That'll be the value of T. Okay, and if you use a calculator to find the value of T, okay, T would be equal to 15.7. Okay, now what we do is after finding T, we get T and substitute back to T in one of the equations. Now find the value of P by substituting 15.7 for T in either equation. So what it's saying is this: we will get this value of T, 15.7, and we will substitute it back to either one of these equations. So it doesn't matter which one. You can do it for equation number 1 or equation number 2. It's your choice. So if we get that value of T, substitute it back, okay, this is what we get. We use P equals 18.2 plus 0.03T and get the value of T, substituted to that T. Okay, we end up with 18.2 plus 0.03 times 15.7. Okay, and that would be 18.67. So P will be equal to 18.67, and then we have to check our equation if it makes sense or not. So in each equation, replace T with 15.7 and P with 18.67. Okay, and you notice that it will make both equations true after we substitute 15.7 and 18.767 for T and P respectively. Okay, so the solution of the system of equations is 15.7 and 18.67. Therefore, after 15.7 years, or in 2013, the populations of New York and Florida would both be 18.67 million. Okay, now it's your job now to check online to see if this is true or not, because this book was printed way before 2013. And let's see if the prediction came true or not. Okay, so if you compare this result to the estimate, okay, our estimate is around 16 and 19. It's pretty close, but then again, it's not an exact answer. So using the graphing method is not really an exact answer for this one. Okay. And let's take a look at how to do this using substitution method by looking at example number 1. Example number 1, use substitution to solve each system of equations. X plus 4y equals 1 and 2x minus 3y equals negative 9. So what I would suggest always is you number your equations. This is equation 1 and this is equation 2. Okay, so let's use substitution method. Okay, so solve the first equation for x since the coefficient of x is 1. Okay, the reason why we're now using equation 1, okay, and we're solving for x. The reason why we're solving for x is because the coefficient of x, or the number before x, is 1. So we don't have to do a lot to be able to solve for x. So to be able to solve for x, we simply subtract. Okay, we copy the equation, and we simply subtract 4y to both sides. You end up with x equals 1 minus 4y. So after we found the value of x for equation number 1, we go to equation number 2. So next, find the value of y. Okay, again, this is equation 2. Okay, next, find the value of y by substituting 1 minus 4y for x in the second equation. So in equation 2, we get 1 minus 4y and substitute it to that x right there. So we copy the equation, 2x minus 3y equals negative 9, and we simply substitute the value of x. Okay, so if you notice, okay, 1 minus 4y has been substituted for x. So now you have 2 times 1 minus 4y minus 3y equals negative 9. And we simply solve for y. Okay, distribute. Okay, remember we need to simplify this expression before we can solve for y. Okay, and then we end up with negative 11y equals negative 11. Okay, subtracting negative 2 to both sides and adding negative 8y minus 3y. And then we simply divide both sides by negative 11. We end up with y equals 1. Okay, so now we found the value for y. So after finding the value of y, we then substitute 1 for y in either of the original equations and find the value of x. Okay, now again, one hint right here in blue is choose the equation that is easier for you to solve. So now you've found the value of y, which is y equals 1. Okay, to be able to find the value of x, okay, choose an equation that's easier for you to solve. And I would suggest you use equation 1. Okay, well, let's see if the book uses equation 1, because equation 1 is simply x plus 4y equals 1. Smaller numbers, easy for us to solve. And indeed, the book chose that one. Okay, so x plus 4y equals 1. We simply substitute the value of y. And then we end up with x plus 4 equals 1. Solve for x, we end up with x equals negative 3. So our x, or our y, is equal to 1. Our x is equal to negative 3. Therefore, the solution for the system would be negative 3, 1. Okay? Now use the graph to the left to verify this result. We go back to our first method of graphing. And if we graph both equations, you notice that it does intersect at negative 3 and 1. Okay? Let's take a look at example B. 5 halves x plus y equals 4, and 5x plus 2y equals 8. Again, if you notice, okay, we have equation 1, and we have equation 2. And if you look at equation 1 closely, you have y, which has a coefficient of 1. Therefore, we can solve for y easily in equation 1. And that's exactly what we're doing. For the first equation, we are solving for y since the coefficient of y is 1. Okay, so if we solve for y, simply subtract 5 halves x to both sides, we end up with y equals 4 minus 5 halves x. And then this is again using equation 1. And in the next step, we use equation 2. Okay, we get 4 minus 5 halves x and substitute it to the second equation. Okay, this one right there. So 4 minus 5 half x has been substituted for the y right there. Okay, so that y has been replaced with 4 minus 5 halves x. Okay, and then we simplify the expression on the left side. We have 5 halves x plus 8 minus 5x using the distributive property. Add like terms, end up with 8 equals 8. What does this show us when you don't have any more variables? This simply means this. The statement 8 equals 8 is true. That means that there are infinitely many solutions to the system of equations. This is true because the slope-intercept form of both equations is y equals 4 minus 5 halves x. And if you remember what we talked about, okay, these two lines are coincident. That means they lie on top of each other. Okay, so that means the equations are equivalent and both have the same graph. Okay, and this is actually both their graphs right here. So they lie on the same line, and when you end up with this type of a result, that means you have an infinitely many solutions for your system of equations. Okay, and let's take a look at the last example. No, two more examples. Okay, example 2 and example 3. So example number 2, sometimes it is helpful to organize data before solving a problem. Some ways to organize data are to use tables, charts, different types of graphs, or diagrams. And we go back to your favorite part of algebra, which is a mixture word problem. So example number 2, EGH Labs needs to make 1,000 gallons of a 34% acid solution. The only solutions available are 25% acid and 50% acid. So how many gallons of each solution should be mixed to make the 34% solution? Remember what we talked about, okay, in a mixture problem. Okay, so you want to create 1,000 gallons, okay, of an acid solution that is only 34%, okay, solution, and you want to mix a 25% solution and 50% solution. Okay, so in a mixture problem, what is important is a table like the one you see here. Okay, and when we solved this in the past, we used only one variable to solve this. Okay, now we know how to solve equations with two variables. We'll do that right now. So we will use our skill of on about solving systems of equations to solve word problems such as this one. So what do we know? We let A represent the number of gallons of 25% acid solution, and let B represent the number of gallons of 50% solution. Again, we make our very popular table, organize the information in the problem. So the total percent of 25% acid would be A, because that's how we represented it. Number of gallons of 25% acid, and we let the 50% acid, okay, to be B. Okay, so gallons of acid for 25%, obviously, since it's 25%, make that into a decimal would be 2.25A. Okay, and for the 50% acid is 0.5B. 34% acid, okay, remember that this would be equal to, the total of gallons would be 1,000. Okay, and when you want to find the gallons of acid in a 1,000 gallons with 34% acid, that would be 0.34 times 1,000. So if you notice, we already have two systems of equations, and if I simply put a plus here and an equal sign there, a plus there and equal sign there, you'll have your two systems right there. Okay, so the system of equations would be a plus b equals 1,000 and 0.25a plus 0.5b equals 0.34 times 1,000. Okay, now we will use substitution to solve the system. Why substitution? Because if you notice, the coefficient of a and b, okay, are 1. So that means if the coefficient of a and b, well, actually the coefficient of a and b is 1, right? So if the coefficient is 1, all we need to do is subtract one variable to both sides. We can either subtract a or we can subtract b. So we'll subtract b in this instance. So since a plus b equals 1,000, a equals 1,000 minus b, and substitute it to our equation number 2. So this becomes our equation 1, and this becomes our equation 2 right there. Okay, so we substitute a equals 1,000, b to equation 2, that a right over there. So you end up with this one, 0.25a, okay, plus 0.5b. We simply copy the equation and we substitute 1,000 minus b. Okay, so 1,000 minus b has been substituted to this a right there, and that's why I end up with 0.25 times 1,000 minus b plus 0.5b equals 340. Let's simplify that expression by distributive property, and further simplifying it will give you 0.25b equals 90. Dividing both sides by 0.25, end up with b equals 360. Now we found the value of b. We are now going to substitute b to our equation 1. So we go back to our equation 1, a plus b equals 1,000. Okay, and then substitute b, which is 360, equals 1,000. Then we subtract 360 to both sides, end up with a equals 640. Now we found the value of a and b, thus 640 gallons of 25% acid solution and 360 gallons of 50% acid solution should be used. And if you want to check our answer, 34% acid solution contains 0.25 times 640. We simply substitute a and b, okay, to an equation, plus 0.5 times 360 will be equal to 160 plus 180, or 340 gallons of acid. So the answer checks out. Okay, and that's how you use a system of equations to solve a mixture problem, such as example number 2. So let's take a look at example 3. The system of equations can be useful in representing real-life situations, solving real-life problems. The Williams family is going to the Johnstown Summer Carnival. They have 2 ticket options as shown in the table below. So one ticket option is the price of admission is $5 and the price per ride is 30 cents. Second ticket option, $3 is the admission and you have 80 cents per ride. Okay, so write an equation that represents the cost per person for each option. Letter B, graph the equations and estimate the solution. Explain what the solution means. Okay. Letter C, solve the system using substitution. And letter D, write a short paragraph advising the Williams family which options to use. So let's get to it. Letter A, it's asking us to write an equation that represents the cost per person for each. Okay, cost per person for each. So we let R represent the number of rides. The total cost for C for each person will be the cost of admission plus the cost of the rides. This is very logical. So the cost will be the cost of admission plus the cost of the rides. That is the total cost. Okay, if we follow this, we end up with, okay, we end up with C equals 5 plus 0.3 R. Example 3. We have example 2. I think we have example 2. Okay, so 5 plus 0.3 R. The cost of rides is the price, okay, is the price per ride times the number of rides, and option B would be 3 plus 0.8R. Okay, so letter B, asking graph the equations, and if you graph our equations, we can estimate the solution. So we can estimate from the graph that the solution is about 4, 6, because if we graph both equations using y equals mx plus b, where this is your y-intercept, and this is your slope, 0.3 and 0.8 will be your slopes, you end up with these two graphs, and this is where they intersect right here, which is around 4, 6. This means that when the number of rides is equals 4, both ticket options cost about $6 per person. Okay, so the intersection of those two lines means that when the number of rides equals 4, okay, both ticket options cost about $6 per person, and that's what the ordered pair 4, 6 means. Okay, and in letter C, use substitution to solve this system. C equals 5 plus 0.3R. Okay, and then we simply substitute C. Okay, we substitute C, 5 plus 0.03R to that particular C right there, and that's the reason why you have 3 plus 0.8R equals 5 plus 0.3R. Okay, so replace C with 3 plus 0.8R, and from there we simplify the equation. Okay, we basically subtract, okay, 0.3R to both sides, and we subtract 3 to both sides of the equation, end up with 0.5R equals 2, and divide both sides by 0.5, end up with R equals 4. Okay, so C equals 5 plus 0.3R. Okay, so after finding the value of R, and we go back to C equals 5 plus 0.3R, we substitute now the value of R, which is 4, and we end up with 5 plus 0.3 times 4, and we end up with the cost, or C equals 6.2. Okay, so the solution is 4 and 6.2. This simply means that if a person rides 4 rides, okay, both options cost the same, $6.20. And from the graph, you can see that option A, tickets will cost less if a person rides more than 4 rides. Option B, tickets will cost less if a person rides less than 3 rides. Okay? Letter D is simply saying that you should advise the Williams family to purchase option A tickets for those who plan to ride more than 4 rides, and purchase option B tickets for the rest of the family. Okay? So, this is how you use your system of equations to be able to solve a problem, a real-life problem such as the one that we just finished. Okay? And the secret word for this lesson would be New Jersey. Secret word for this lesson would be New Jersey.